attendees are in listen-only mode. Muted.
Good afternoon, everyone. This is Mark Albert, Editor-in-Chief of Modern Machine Shop Magazine. Welcome to our webinar sponsored by FANUC FA America. Thank you for joining us. Our topic this afternoon is CNC Programming Made Easy with Manual Guide Eye Conversational Programming. And this is part 2, Creating a Basic Turning Program. Without particular knowledge of G-code programming, it is possible to generate part programs on the shop floor by answering simple questions. FANUC's Manual Guide Eye Conversational Programming provides this capability for milling, turning, and mill turn centers with FANUC CNCs. Part 1 gave an overview of the functionality of Manual Guide Eye. Part 2 builds on that introduction by reviewing the entire progression of creating a basic turning program with Manual Guide Eye. Today's session covers selecting fixed forms, tool selection, cutting speeds, and feed rates for various materials. Our presenter this afternoon is Jody Michaels. As End User Account Manager for FANUC FA America, Jody Michaels' focus is on servicing and supporting end users to maximize their productivity with the use of FANUC CNCs. Jody has 35 years experience in the machine tool industry with various positions in sales, support, automotive applications, and training at machine tool builders, end users, and CNC suppliers. He is a true expert on CNC programming and the functionality, setup, and use of Manual Guide Eye. As we listen to Jody during the presentation, please feel free to share your questions with us by typing them in the questions pane on your control panel. Jody will answer those questions at the end of the presentation. Keep in mind this webinar is being recorded, so you'll be able to review the entire program online later. Thanks again for taking time to be with us for the live program. Here's Jody.
Thanks, Mark. Good afternoon, everyone. As Mark says, we are doing part 2 of a 3-part series today. And what we're going to do today is a basic turning program, the entire sequence of events that you have to do to create a new program, a turning program. And what we're going to do today, it's a very simple part, and it's something that we all would recognize. It's a 2-inch trailer hitch ball. And it's got a lot of different features that could be complicated when you're programming it, but actually Manual Guide Eye makes it very easy. This is just a picture of it. And then this is an actual print of the part. So we've got all of our dimensions, and I know none of you are going to have time to actually make a drawing of this, but I've got one here, and we'll go through the entire process of making 2 sets. We'll do an A and a B set. The first side, what we're going to do is the actual ball and the relief and the flange. And then on the B set, what we'll do is the left-hand side where we actually turn down the diameter and chase the thread on the back side. And again, what we're going to do today is like what we did a few weeks ago when we did the setup. We're going to use NC Guide and actually use the interactive Manual Guide Eye to actually do the programming. So at this point, what I'm going to do, I'm going to change my screen, switch programs, and we actually go into the NC Guide. And now to start a new program, you always want to go into the edit mode. And when we go into edit and go left shift, so this will typically be the screen when you first go into the edit mode. And what we want to do to start a program, you press the new program soft key, and then you give it a number. With some of our controls, you'll actually be able to give it a name. But with the model we're using today, the 0i Model D, it still wants a number. So we're going to say number 4. And see, it starts a new program. And then typically what I do at the beginning, and again, I want to emphasize what we're showing today with the flexibility of Manual Guide Eye. I'm going to show you the way that I typically do the program, but you don't have to do it exactly the same sequence I do. once you start using Manual Guide I, you're going to come up with your own methodology of how to make a program. And, that's fine with me. You don't have to do it. It doesn't have to be my way. But at this point, here's what I do. Usually I'll go into the O list where you can edit a comment, and then I'll put a description of what we're doing. 2 trailer hitch. Enter that. And then when we go back into our program, see it puts a description there in parentheses. So that's how we start our program. Now the next thing I typically do is go right shift, go into our start soft key, and there we have a tab to the right that's called blank. What we need to do is define the material that we're going to make this part from. And this is only for simulation. It doesn't have anything to do with actually cutting the part. It's only for simulation when we get done actually making the program. And what we're going to do is a cylinder blank figure. We select that, and it will automatically default to whatever you entered into these fields the last time. But I know for the part that we're making today, it's 3-inch diameter, so you type in 3, input, then the length is 5 inches, input, and then the work origin Z, that's just asking what the face of the part is. And we're going to face the end of the part like you typically do on a lathe to set up a datum point at the end of the part. So I'm going to say we're going to have 100 thousandths on the end of the part. Input that, and then press the Insert Soft key. It's important whenever you're inputting information into a cycle in Manual Guide I that you use the Input hard key to put in information and only use the Insert Soft key when you're done. So if you try to press Insert to actually put the information in the field, it'll try to input the entire thing into the program, and you won't be done, and you'll get an alarm. So at this point, we press Insert. So at this point, we've got 2 lines in our program, and it's just one is the program number, and the next one is the actual blank. And you see it gives a description of what that G code is down here, G1900 cylinder blank figure. So you can understand what that is. Now at this point, we have to go into our fixed form soft key, and this takes us into the fixed forms we developed in our first part of our series. So now at this point, what we want to do at the beginning of any program, you're going to have start lines where you just modal commands that you want to make sure that are in effect. And as you can see, we have an alarm that says imperfect word must be changed. And the reason that is, in our start lines, there are certain places where I leave question marks so that you can go in and put in what information that you want there. Because right there, it's going to start up the spindle. It will say S100, alter. You just highlight it with a cursor, type in what you want to change it to, press the alter key, and it changes it. And it's asking for a feed rate. Now this feed rate, you would think you wouldn't have to do this because you're going to put a feed rate in the cycle. But if you don't put a feed rate here, occasionally, if the control does not pick up a default feed rate when you go to run the program, you'll get an alarm saying no feed rate commanded. So that's why I always try to put this in my start line, just to keep you from getting an alarm further down the line. So it makes it very helpful to do this at the beginning. So we'll say 0.01, alter again. So now we put our start line, then we go back to our fixed form. We want to do a tool change. We insert that, and again, we get the imperfect word must be changed. And see, if I put tool with a T number with question marks, because I didn't know what tool I was going to use. But I know for what we're going to create today that we have to have a tool that has some relief on the back side. So I know that's 3. Tool number 3, 0303, alter. And then I usually put a description. So I know that's a 55-degree tool. It's spelled very well. And then alter again. And so now, and the reason I do that is, say we run this program a year from now, we can go through and look at the tool descriptions and see like a tool list, so we can retool it. And then also, if we put the cursor over the entire line where the tool number is, see it gives a description. And if we press the input key, it takes us into our tool data screen. And we can see tool number 3 is a general tool with a cut angle of 93 degrees and a nose angle of 55. And that's the tool that I want. That's the tool I want to use to rough out this part. Now the next thing that I typically put in at the beginning of the program, again we go into fix form, and it's a positioning move. Now this is something that I do. If you read the Manual Guide I manual, it won't ask you to do this, but I like to do it because I like to ensure before you go into a cycle that I know exactly where the machine is going to go. I don't want to leave it to the leisure of the control itself to decide where that is. I want to go to a known spot. And, you know, like Programming 101, typically you would go 100 thousandths above your stock and 100 thousandths in front. That's what I always do. X 3.1, then alter, just like before. Put the cursor over what you want to change, and then 0.1, alter again. So now we've called up the tool. We're at a clear position. So now at this point, what we want to do, we want to call up a cut speed for the material that we're going to cut. And the material we're going to use, this is 4142 preheat treated material. And most all of you are going to understand what that is. And let's see, I have a selection for preheat treated roughing cut speed. We insert that. And again, it says imperfect word must be changed. And it's asking us to give a spindle limiter. So we'll say we want to only go up to 1500 RPM. And alter again. So at this point, we've done all the preparatory work to get a tool, start the spindle, set up our cut speed, set up our max speed, and our feed rate. So now at this point, then we can actually go into the cycle to actually turn this part. So we go to cycle, and we want to go into turning. And turning outer rough is what we want to select. So I want to do several of these selections today. So this is the first one we're going to do. We select that. And again, as we went over in our overview in part 1, it's just fill in the blanks. And if the control is going to give you any answers, there'll be a soft key down here. So it says, okay, which direction are we going to go? Z minus, that's what we want. Then depth of cut, this is a radial depth of cut. So for this tool, we're going to say 60 thousandths, 0.06. Input, rate of cut depth percentage, leave that at 100. It defaults to that. Then this is the x-axis finish amount material. This is the amount of stock it'll leave for a finished pass. So I always leave 10 thousandths per side. Then 5 thousandths on the shoulders, 0.005 input. And this is our feed rate again, 0.01. And then this is our relief feed rate, 5. And then this is when it comes out of relief, 0.005 there also. Then we arrow over to our detail data. And it retains what we had the first time. First feed overrides 100%. The cut rise method is always cut rise. And the escape amounts are 100 thousandths. And then the move to start the cuts, the vector move. And then the third tab is in-face machining, either available or not available. And we want it available because we want it to face the end of the part, starting in X and feeding down to X minus. So we'll say there's 100 thousandth stock on the end of the part, enter that. Then we press insert because we filled out all the different tabs. All 3 are completely filled. We press insert and see what it does. As soon as you fill out the machining cycle, if there's any geometry that's to be associated with that, it'll force you into where you describe the geometry of the finished part, not of the rough stock, of the finished part, the finished profile. So for this, with the part we're describing, it wants the start point, and that's 0 and X, 0, enter, 0 and Z. You don't have to allow for out in front of the part, because that's within the cycle where we told it to start 100 thousandths away. So it's important when you do this geometry trouble most people have is they try to give it too much information. You only need to describe the finished profile. The software is very, very astute. It'll figure out where to start from. It'll figure out on its own. So then we say, press the OK off key, and see it draws the start point. So the first one we have to do is we know at the end of this part there's a flat on the end of this ball. So we need to do a line up that first diameter. And see, it gives you all these different directions for where we're describing what we're doing. And we're starting at 0, so we're going to go up. And the finished dimension is 931,000 2/10. So 0.9312, enter that. Now the next 3 fields, typically, you don't have to put anything there. The last connection and the next connection, you only put something there as if you've got a line that's going into it, meeting something on tangent. That's the only time you ever change those, the next 2. And then the last one, it's just asking you what we are describing, the part or the blank. Those are your 2 selections. Right now we're describing the part profile, so we leave it at part. Then we say OK. See, it draws a line. And at this point, it doesn't really have any scaling because it's the only part of the geometry we've described. So now the next thing we want to do, we have to describe the arc. And it's a counterclockwise arc. So we press that. And within this, you see how all the first 5 fields all have asterisks. Because depending on your print, you can have a variety of different information here. So what we want here, we're going to tell it, we know the radius is 1 inch. Enter that. We know the center point is x0. And we know the center point in Z, if you draw a complete 1 inch radius, is minus 1 inch. And again, nothing in the next 2. And then the element type is the part again. And when we press OK, you see it draws a complete circle. The blue line is the straight line that we described. And then this is the circle. And the reason it drew a complete circle is we didn't give it any endpoints. And the control is going to figure out where the endpoint is based on what we do next. So at this point, we know that there's a line that's going to the left. And the endpoint in Z is minus 2.595, and enter that. And again, we don't need anything there. Then we say OK. And we're going to do a line to the left. And the endpoint in Z is, the endpoint in X is 1 inch. And minus 2.595. And again, you don't have to change any of those. Say OK. See what it does. It drew this line, the blue line, because it knew where the endpoint was. And then it drew this. And if we go next, it says if I draw that line, I'll cross that radius in 2 spots, either there or there. So we know that the one we really want is this one. Okay? So we say select. See, now it draws all this correctly. And the reason we've got where the yellow is, that's where it's drawn the line. Now at this point, we say, darn it, we forgot at the end of this radius. And you see up here at the top, it's showing all the different elements we're describing. At this point, we know that here, I'm supposed to put a radius at the corner of that, but I ignored it intentionally so we can go back and add it to show you how easy that is to do. So we know there's supposed to be a 1/4 inch radius at the corner there. So we put 250, enter, and then say OK. And see, it immediately adds the radius. And so now here we're to this shoulder. And now at this point, I know in this corner there's also a radius. It's a 450 thousandths radius. Enter that. Then say OK. Now the reason it didn't draw it yet is because we haven't told it which way to go yet. So we're going to do a line. And we're going to go up. And we're going to end up at 2.5. I'm sort of taking liberty with the drawing. I want to make the flames to be a little bigger. Enter that. Again, we don't need to change any of these last three. We say OK. See what it does? It drew the radius, a real small flat, and then another big radius. Now up here on the top, I want another corner radius, 60 thousandths. Say OK. Again, it didn't draw it yet because it doesn't know which way to go. Now at this point, we're going to do another arc. And I know the end point this time, we want to go 2.5. And then I don't remember where I told to go in Z, but if we press this starting point minus incremental, if we press that, it remembers where we are. So I want to go another 0.5. Enter that. So now it knows where it is. And we'll say it's a 1.5, a 1.3 radius. Enter that. And then say OK. See, so it draws the radius. So now we've described the entire profile of what we want to do. Now the last thing you want to do is do another line. Now this one will go up. Now this is where you actually describe the material that we're cutting this from. We know it's 3 inches, 3. Now this time we go down to the last field where it says part. Now we want to make it a blank. Okay. The last thing you do in your geometry is describe the size of the material. Then we say OK, and it'll draw that line. Okay, at this point we've done all of our geometry for the right side of the part. But now with Manual Guide I, it's very critical that you have to do it. It has to be a closed figure. So at this point, if you press the right shift key, this key, the right arrow key, 4 times, 1, 2, 3, 4. And we went through a bunch of fields there. And at some point in our next sequence, we'll go over all individually what all those are, but we don't really have time to go through them all individually today. But now we have a soft key that says BL Continuous. We press that, and it brings up, it gives you 2 selections, Figure 1 or Figure 2. Figure 1 is an OD, Figure 2 is an ID. So we're doing an OD, we say Figure 1. It says select blankest connection. Yes. It's saying, are you sure that's what you want to do? Yes. Okay. And at this point, it goes back to that screen, but it gives us a soft key that says create. And that's what we want to do at this point. Press the create soft key. And we got 2 things we can do. We can either insert all this geometry in our current program, or we can create it as a subprogram. You can do either one. For right now, we're going to do the first one. Insert in current program. You press the OK soft key. And what it does, it goes through and adds all that to our current program. Now again, what we're going to do right now, my method, whenever I do a program in Manual Guide I don't go through and program the entire thing. I like to go through each cycle and simulate it as soon as I get done with that cycle. So at this point, just to make sure that what we're doing is correct, we're going to go to Auto, SimLab. I know simulate wasn't spelled right, but that's the way it is. Now rewind. It'll take us back to the start of the program. If we press Start, you can see right now, as it's simulating, see the tool. It looks like what we described. It's a 55-degree tool with 3 degrees of lead on the front. And also, see how we're getting this message, cutting residue will occur. And what that's doing, it's looking at the angle we described on this tool. And it's saying once it goes in and does the relief on the back side, that tool will not be able to get in there and cut all of it. But with this tool, it will only do what it can. So here's what we'll go ahead and start it again. It'll go ahead and finish it, what it can. So you can see the geometry here is not exactly what we described, but it did whatever it could do with that tool. And the reason we got an alarm is because we don't have an end program yet in our program. So at this point, what we need to do is group off. Whenever you want to get out simulation, you press the group off soft key. That takes you back to your original screen, and we go back to edit. So now we know at this point, we have to go in there with a different tool to semi-finish it or finish it to get to the right profile. So now what we need to do is just like before, we go back to our fix forms, and we're going to do another tool change, just like we did before. Now this time, I know tool 2 is a tool that we'll get into what we want to do. So tool 2, alter, and the description of that, it's a 35 degree. And then we alter that, just like we did before. And again, if we highlight the entire line and press input, it takes us right into our tool data selection. So it's a general tool with a 35 degree tool. That's what I want. So at this point, what we want to do with that tool is go to fix form. And again, we want to do a turn on our cut speed again for pre-heat treated material. Insert that. Limit our RPM. The reason we're doing this is where if you wanted to only go through this tool, you could go to this section and start only for that tool. You don't have to go through the entire program. You can start wherever you want. So it makes it very nice for starting in the middle of the program. Then alter that. And then again, we'll do a positioning move like we did before. Positioning move. Insert that. And again, this is something I do. You don't have to do this yourself. I just like to do it because then I know exactly where it's starting from. I like to have a little bit of control for that. Point 1, alter that. So at this point, we've done tool change. We called up our cut speed. So now what we want to do is go back to cycle, turning. And now this time, we could either do semi-finish or finish, either one. So we're going to do 2 finishes. And we'll select that. And again, the finish cycle is much simpler. There's not very much to fill out for Z minus. And a feed rate, we'll slide down, enter that, then insert that. And again, see, it takes us into where it wants us to describe the finished profile again. But we don't want to go through all that hassle of drawing that again. So we'll say cancel, cancel. And now what we're going to do, we're going to up and copy where we described it the first time. So we go to 1450 will always be the beginning of it. And at this point, we're sort of locked up at this point. But let me see if I can set it off and start it back up and get back out of it. Sorry about that. Get back into the time. Sometimes it will go into a loop where sorry about that. Let me see if I let me just on that. Yeah, see, it's sort of locked up in a loop. Yeah, I apologize for that. Let me just exit out of those and let me start it back up. This will get us right back to where we were, no problem. Again, what we're going to do now, we're going to copy the geometry of what we were working on before. So this will just bring us right back into NC Guide. And it will have saved where we were before. See, it's just booting up again. And it looks, the good thing about NC Guide, and this is a good way of showing how it starts, it looks exactly like the original control. And we go to edit, and we're right back to where we were. All I'm going to do is go down here, and as I said, I want to copy from this point. I want to copy. If they'll let me do that. Okay. Try this one more time. One more time. And I apologize for the delay here, but we'll get back here on track in a second. It'll boot up again. I'll do it differently this time. Shooting up the control again, like I said, NC Guide. The good thing about it for training, it's very invaluable because it shows the control exactly like what you would use. So I'll turn that off. Edit. And we're on page down. Now this time, it shows the profile. And I'm going to copy. I'm going to arrow all the way down to 1456. Just the last line. We'll say copy. And then we just page down to where we did the finished profile, and then we just paste it back in. I'll see now, all we did was just went in and copied the profile from the rough. We didn't have to redraw it. We didn't have to make mistakes. So now we go to Auto. We're going to SimLab. We're going to start it again. See, now it goes through and roughs it with a 55. Now it goes in with a 35. So see, now it looks like the actual profile of what we wanted. So at this point, we've roughed it, we've finished it. So now the right end of the part is actually done. So now at this point, like I said, we go back to Group Off. So we know at this point, we go back to Edit, and we page all the way down. Now at this point, what we want to do is we go back to our fixed forms, just like before. Fixed forms just like before. It's not going to cooperate with me today, but that's okay. It's a test. It's just a test to show you how easy it is to get in and out of it. Obviously, it wouldn't do this to you on your control. This is mainly has to do with my computer. And again, I apologize. But we'll get right back into it. And what we're going to do next is we're going to put a program stop in the middle of our program because we've concluded the A set of our program. Typically with a part where you can't do the entire thing from one side, you'll have an A and a B set. So now we're going to do the other side, the B set. Okay, we'll reset that, run edit. We're going to page all the way down to here. We're going to go to a fixed form. And what we're going to do is our program stop. Let's see where it is. See, we got program stop, turn part around. We insert that. That'll let you know when you get to that spot, we have to turn the part around. And then we're going to do a fixed form. We're going to do a tool change. I know for this one, it's tool 1, 0101, and alter. And I know for this one, it's an 80-degree tool because what we're doing on the back side, there's no release where we have to use a tool with release line. So we can use an 80-degree tool. It's stronger. We can take a bigger depth cut. And then alter that. So we call that tool out. Then we go to fixed form. We want to do our cut speed, our preheat tree cut speed. And again, we limit it. That's 1500. Alter that. And we want to do a position move, just like I told you. What I always like to do is a positioning move to know where I'm going. We insert that. Again, imperfect word must be changed, X 3.1. But we're still using the same material. Alter that. And Z at 0.1, alter that. At this point, we need to go in and describe our blank again. So it'll draw a new one for the back side. So like that. It retains what we had before. We still want to use that. Insert that. So at this point, we're ready to go in and do our cycle. So we do cycle and turning. Now this time, we're going to do outer rough and finish from the same tool. So we can use the same tool this time. So again, Z minus our cut direction. 0.1 is our depth of cut. Finish stock 0.015 on this side. 0.005 on there. Our feed rate is 0.01, 0.005 on our other two. And then now this time that's for a finished feed rate, 0.004. And it defaults, it retains what we had on our detail. Then we always will say available for the face the end, 0.1, enter, and then insert. So again, now we have to go describe our profile. Now with this time, we go in, we're going to start at 0 again, and 0 and Z, and say OK. And then we'll do a line, and our diameter going up is 1 inch. 1 inch. We don't have to put anything on the next 3 just like before. But we do want to put a corner chamfer because we're going to chase threads on this side. So we'll put 0.125, an 1/8 inch wide chamfer. It'll be 45 degrees. Again, it didn't draw it yet because of it doesn't know which direction to go yet. So we say line to the left, and we'll say minus 1.575. Okay, again, we don't have to do anything for those. And say OK. It draws the line with the chamfer here. And we want to do a line up to 2.5. That's where we ended up on the other side. Say OK. So it draws that. We want to put another corner radius there, 60 thousandths. Say OK. It didn't draw that yet because we didn't know where to go yet. So a line to the left. And if we press the start point minus incremental, we press that, it remembers where we were. We want to go another 100 thousandths, so 0.1. It does the math for you. And again, this is still part. Okay, so it draws the small yellow line here. Now the last thing we want to do is we want to go up to our stock size, 3 inches. And again, but now this time it's the blank again, the blank. All right, so that's very simple. The last line is the actual blank side. And we say, OK. It draws that. So at this point, if you remember what we did on the other side, we have to close that figure. Again, it's right shift 4 times. 1, 2, 3, 4. DL continuous. Number 1 is an OD. Number 2 would be an ID. So it's still number 1. You say, yes, we want to select that. So we want to create. Now this time we're going to create a subroutine, a subprogram, just to show you what it does when you do that. And we're going to say 522 is our thread. We're going to describe it. We say OK. See what it does instead of inserting all those lines within the program, it just puts one line. And it tells you what an M98 is. I call the subprogram number 522. So at this point, we've done all the geometry for the backside. So we go into Auto, SimLab, Rewind, and Start. And it does all the first end. Does all the relief. And it goes in with a 35 and finishes that. Now it does the other side. It turns it all down. So now we've done all that. So now what we need to do, turn group off, because now we've got to add a thread to it. I want to show you how easy that is to do. Thread. Today it's definitely bulky here. It doesn't like me much today. That's all right. We'll get back out of it. Start it back up. Again, I apologize for this. It's got something to do with my computer. But now what we need to do next is add a thread tool and then do a thread. It's just 2 lines of code. Very simple. Very simple. So we go back into horizontal T. It brings NC Guide back up. Just like before. And all we need to do at the end of the program, as I said, is just add our threading tool, which I know is tool number 10. And so we go into our fixed forms. And we're going to do a tool change. And it's, like I said, it's tool 10. Alter that. We go over here and say that's a thread. that. Now this time, in our fixed form, we only want to start to spindle. You don't want to use cuts constant surface speed when you're doing the thread, and it starts at 500. We're all right with that. And we do a fixed form to do a positioning move. Insert that. Again, it's X3.1, 3.1 halter, 3.1 halter. Then we just go into cycle, threading outer or inner. We want outer. It's very simple. Just fill in the blanks. Single depth. Anything with an asterisk, you don't have to answer that. The finish amount, we could leave more finish stock for the last pass. This is the number of finishing passes. Cut depth, and we're going to say 0.01 for depth cut. And the details, just the approach moves. Then we insert that. And we want to do a unified thread because it's a standard inch thread. We select that. And again, it's just fill in the blank. The thread diameter is 1 inch. The start point is 0. It'll start out in front on its own. And we want an 8 threads per inch. The length is 1.125. The depth, it will do the calculation for you for the depth. And that's all you need to do. You press insert, it puts it in the program, so we know we're done now with the program. That's everything. So we put an end to program, insert that, so it's totally finished, the program. So now we want to simulate the whole thing. We go to Auto, Simlat, Rewind, and Start. So it goes in and simulates the entire thing. Finish turns it. It does the other end. And it chases the thread. No problem. So at that point, then you could actually go, if you turn group off, it takes you back to this screen. We could rewind it. From there, you could actually put a part in the chuck, press cycle start, so it would actually go in and run the part. All right? But, of course, we don't want to do that at this point because we're done. What we want to do right now is something I want to show you, and we're almost finished here. But, okay, you've run a part using the conversational. Now, at this point, you say, now I want to convert it to a G-code program. And it's very simple to do that. At this point, we're in auto or memory or whatever your control might say. If you press the right shift key, you have a soft key that says NC Convert. You press that, and it says, okay, give me a different number, 5. Okay, so now it's got a split screen. So we press Start. See, it's going through and reading the program on the right-hand side and creating a G-code program on the left side. And they're all just straight point-to-point moves. In turning, in drilling, it'll use drill can cycles, and in threading, it'll use a can cycle, like a G78 or a G92. But right now, it's actually creating a real G-code program on the left side, something you could take from this control or your machine that you're using, take it out of that and put it in another machine with a FANUC control that doesn't have manual guide on. You could use it. G-code is G-code. You could use it wherever you'd want. So it's very powerful that way. Now it'll take a few seconds for it to make the G-code program all load finish. Then the last thing I want to show you before we go into our questions, there's also a way where it will do a time study too, where say you're a small shop and you want to figure out how long it would take to make a part, it will do a time conversion too, based on whatever your cut speed and everything are. So if we press the return, and at this point, if we go to Edit, okay, and you go right shift, okay, I need to go one back, where it says Simlat. You go to Simlat, then right shift again, and we'll get to where we have a key that says Insert Time. Okay, we press Insert, and it says Machine Time Data is inserted. Okay. See what it did up here where it says time 7:55, A14. What that is The actual cut time is 12 minutes and 35 seconds, and the non-cut time is 14 seconds. And the reason that's so low is because in this simulator it does not actually have feedback from the spindle. So that's why. But with a real machine, it would have real values there. So at this point, that's all I really wanted to show today. I think we've went through the entire process. We've gone through an entire program. So all I want to do here now is this, and we go right back into where we were. So I'll turn it back to Mark where we can go through any questions we might have.
Okay, thanks, Jody. That was really interesting. I guess having sat through part one, part two, it just had a lot more to offer here. Yeah, we do have some questions, so we're going to jump into those. One of the questions is about cutting threads other than 30 degrees, and in parentheses, it's buttress or Acme.
Right.
Can you help us answer that one?
Sure. So I think you noticed when we did the threading cycle on this particular part, it gave you several different choices about describing the thread itself. And within the general thread data, it's the most powerful because with it you can give it an X and a Z start point and an end point. So you can do angled threads that aren't typical tapered threads. And plus you can describe in your tool data the different angles of what the tool might be. Because, like with an Acme thread, it's going to be like a 14.5 degree, it's 29 degrees is the total angle on the tool itself. So you can describe that, and then the control itself, the software will pick up that angle the way it feeds into the thread itself. So you sort of got to play with it. Now with a buttress thread, most of my experience that I've had with those is typically like the backside angle is actually in the insert itself. And so you can set up the front side to be the correct angle for the buttress thread, and then it will actually form the backside of it based on the insert itself, Mark. That's how it does that.
Okay, good. Okay, another question from our attendees is, how about left-hand threads?
Oh, yeah, that's no problem. So you can tell it to go either way, depending on the tool. I'll say typically on a slant bed, if you're going to chase threads towards the spindle, towards the chuck, you'd have to have an upside-down tool. But if you have a tool that's right side up and go towards the chuck, it'll make a left-hand thread. So there's a lot of different ways you can do it. Different people, if they're going to use the same one or a left-hand thread, the same tool, they'll start to the inside and come towards the tailstock on the machine. Yes, it'll do left-hand threads, no problem. You can tell it to start wherever you want. So that's no problem.
Okay. Question here. When doing profile of a part, would your line moves be opposite versus front or back turret?
No, it would still be the same. It would still be the same. The way I've got, the software I did today was based on the turret being on the top. But it just swings it all the way around. It would still be the same. It would still be the same.
Okay, all right. Jody, how about another question here is from a user, how do you cut and paste in Manual Guide Eye?
Well, that's very simple. And the easiest way for me to show that is to actually show it in Manual Guide Eye. If we go back into it, and we're in a program, and we're in Edit, let me turn the group off. Let's actually cut and paste. If we get to the first Edit screen, you got copy, cut, and paste soft keys here. If we go copy, and we just arrow down, copy, and it asks you to select a range, and then you just page down, and you can see what I'm highlighting, and copy that, and then you just page down to wherever you want to put it. I'll put it at the bottom of the program and just press paste. It's that easy. I mean, it's just like a word processor. So it's very simple. Very simple.
Okay, good, good. Another question here, Jody, from our attendees. How about importing fixed forms?
Yes, for that. This is, people ask this all the time, but you got to get to the right screen to do it. You have to be in Edit. You go right shift until you get to a setting, soft key, the soft key. You press that, and you pick whichever one you want to do, register fixed form sentence for current. Then you have an input soft key. So you press that, and like right now, mine is set up to where I'm looking at a memory card. If we page down through what's on my memory card, we have a file that's called fixform.dat. That's the fixed forms, and you just say input, and it inputs them into the control itself, in the manual.i. And what's good about it is the fixed form file, you can open that up on your desktop or your laptop because it's only a text file. And you could actually edit them offline and then put them back in the machine. So they're very easy to manipulate.
Okay. All right, Jody, one more question here. How about changing parameters in Manual Guide I?
Yes, you can do that also. And typically, you just go into System, and here, that takes you right into your parameters. Now, typically, the parameters for Manual Guide I, they're up in the very high parameter ranges. And that's one thing that I wanted to make sure I emphasize today is some of the things that I showed you today on my Manual Guide I might not necessarily be turned on your version of it. So there might be things that you might need to send us an email. And they're all there, they're just not turned on. So I'm glad somebody asked that question, because there are certain things that you need to turn on. Because different builders will have a different parameter content for Manual Guide I. Sometimes it's not the most optimized version of Manual Guide I.
Okay, all right. Again, we have a little bit more time for few more questions. So if anyone wants to submit a question by typing them into the question pane on the control panel, we're going to try to get to those. And if we don't get to the question while we're on the air, we'll get to them later. I want to remind everybody the webinar is being recorded, and so we'll get a chance to go through it when it's online here. How about this question? How do I go about getting the PC simulator? Is that
the PC simulator? Okay. So, okay, you'd have to contact either your dealer or your local FANUC representative, and it's inside NC Guide. And there's 3 different versions of it, Mark. There's the academic version, which is fairly inexpensive, and it's mainly used for training. You can do programming and training, look at parameters and everything on the academic version, but you can't take the programs you create out and put into something else. And then there's a version just NC Guide, the middle version, and with it, you got the full capability of doing just like you did before, but you can take the programs from it and put into a machine and actually run them. You can make a G-code program. You can import G-code programs from a CAM system into it, simulate those. So it's very powerful. Then you have NC Guide Pro, which is a version where you can import the ladder, all the parameters. You can set up your offline version to look exactly like the machine that you have it in out on your shop floor. So you have 3 different versions, but you need to contact, like I said, either your local dealer where you bought the machine or your local FANUC representative to do that.
Okay, great. Okay, I've got another question here, and this might be the last question we have time for, but question is, can you adjust the taper of a thread in Manual Guide I?
Sure. Sure. Yes. And the way you do that, Mark, is let me go into the cycle here. If we go into the figure of threads, the easiest way to is actually so. Because if you do an OD pipe thread, it's going to use a 3/4 taper per foot taper. That's just a standard pipe thread. But if you go into general thread, if you select that, because with it, it asks you for a start point in X and a start point in Z, so you can make it any angle you want. Because you know a lot of downhole pipe threads are some crazy angles. It's not 3/4 taper per foot. So this is where you would actually set that up within this general type threading cycle. You can make whatever angle you want, whatever you can imagine to make it.
All right, Jody, let's squeeze one more question in here. It says, my tool description selection for the thread tools appears to only have a 60 degree. Is this a parameter issue? I'm not.
Right. Yeah. Let's see when you go into. Let me go down to my with that here. I think put 29. You know, it'll let you put, you know, whatever angle you'd want to put there. So you're not limited. It might be. I don't think it's a parameter, Mark.
Okay.
No, I don't
All right.
believe. You just have to go to the page.
Yeah. Here's another question, and I think this is a good one. Can you write a program while the machine is running?
Yeah, it does have background edit. Yeah. When you're in edit, there is a background edit. But now, the control's entirely capable of doing it. But frankly, whenever I do training, I usually recommend to people that they don't do that because, you know, anytime you got several different things going on and you're watching the machine run and you're trying to program at the same time, the machine will do it. The control will do it. Yes, that is the answer. I don't recommend it, but it will do it.
Okay, that's good advice, Jody. Okay, I think we got to all the questions, so I want to thank Jody again for presenting the slides and answering the questions. For those attending this afternoon session, you can contact FANUC FA America if you'd like more information, and we're going to get that contact information on the screen. Yeah, here we go. Yeah, okay. And again, you know, if you missed part 1 of this 3-part series, you can find it on our website, MMS Online, under the Webinars tab. And part 3 will be held on Wednesday, March 13th, and we'll focus on creating a basic milling program. So everyone who registered for today's webinar will receive an email inviting them to sign up for part 3, or you can go to FANUC's website homepage to register, and that website is www.fanucfa.com. And so we really appreciate the time everybody's taken to be with us this afternoon, and hope you found it worthwhile. Thanks for taking part. And my thanks also to those who arranged this session, helped it go real smoothly. So this concludes our webinar. Have a great day, everybody. This is Mark Albert at Modern Machine Shop Magazine, signing off.